As we have already seen that in the Manhattan grid problem, the Broadway or the main boulevard, it cuts across the borough and it divides the small blocks into uneven blocks. So by considering that problem, we can even consider a more complex city map or plan, but the recurrence relationship will remain the simple. With the score SV of the vertex V, we can define is as follows. Here we can see we have to calculate the S and V. S is the value weights of the grid and V is the vertex. And we have to calculate the maximum value of the predecessors V. Predecessors mean that the inflow edges. And we have to calculate the value of SU plus the weight of edge from U to V. And U could be more than 2. So predecessors V is the set of all vertices U such that U is the predecessors of V. Since every edge participates in only single recurrence, the running time of the algorithm is defined by the number of edges in the graph. As we have seen, if for example this is a vertex and there are the inflow edges and these are the outflow edges. So the running time of the algorithm will depend on these predecessors. If they are larger in number, the running time of the algorithm will be larger, and if they are smaller in number, the running time will be much better than the others. As we have selected the more complex city plan, but the problem with this more complex city plan is that the solving of the longest path. And we know that this longest path we have to calculate in the DAG grid pattern. And the most important thing in this complex city plan is that we have to consider the order of the edges which we have to consider. We should order it whether which one is to be considered first and which edge is to be considered after that. This ordering is important because while we were analyzing the value of vertex V, at that time, on the same time, the value of SU for all its predecessors must have been computed. So for these types of problems, there are 3 strategies that we will discuss in the next slide. So this is the graphic representation of the problem, and we can see there are 3 strategies that can be used for filling dynamic problem array. So the first strategy will be to fill the array. This is the first. We can fill the array column by column. We can see first we will do this column by column. And we know that we have to calculate or solve the problem in the earlier columns first, and then the later columns will be computed afterwards. So in the second strategy, we will fill the array row by row. These are rows and fill in this direction. And similarly in this strategy also, the earlier rows are filled in before the later ones. And in the third strategy, that is the parallel computation strategy, in this the entries will be filled or computed along the diagonals. And in this technique we can solve the rows and the column simultaneously or parallelly. So these strategies correspond to different topological ordering of the directed acyclic graph corresponding to the perfect grid. And ordering of the vertex, because the ordering is very important, we have to calculate the weight of the vertex, while the algorithm will calculate the SN value of the DAG is called topological if every edge Vi to Vj of the DAG connects a vertex with the smaller index to a vertex with a larger index, that is I is less than j. So here we can see that we come across the problem every day. So our target is to wear up the clothes and reach at this stage. So we can try to wear the clothes in any of the order. The target is the same. Here it is, I think, more clear. So we can see here that it starts from here and we can go in this direction and we end up with the wearing of all the clothes. And in the second condition, again we start up from here and we end up with this, and these two conditions are similar. But we can see here that this is the DAG problem in our daily life. We can see in this one, the cap was wear at this stage. But we can see here that the cap is wear at the end of the stage. So the target is the same. We achieve the same target. So it means that this is one of the edges and this is the other edges. And we can see also here that this long gown is wear at this stage, but this long gown is wear at the second last stage. So these, again, there are differences. What we follow the pattern of wearing the clothes, but the end result is the same. So this is the example of DAG, that we follow a different paths, but we end up with the identical solution.